So this is lesson 4.3, the trig ratios. In the recap from lessons 4.1 and 4.2, we're going to start by finding the a and the radius of the circle using the information given. So we're going to start with the radius of the circle. So theta is always equal to a over r, and if we want to solve for r, it's going to be r is equal to a divided by theta. So our a value in this case is... Our a value is 34 pi, our arc length. That's our a value. Our theta is going to be equal to 17 pi over 15. So we're using this part right here to solve for that. Okay, so I'm going to divide these guys, and what it really looks like is 34 pi multiplied by the reciprocal, which is 15 over 17 pi. The pi's will cross each other off, and then in your calculator, you should get 30. So that is my radius. So my radius is equal to 30. The next thing I still want to find is the a value. Well, the a value so a pi over 15 plus 17 pi over 15 is equal to 2 pi. So we need to isolate for the a value. So I know that in this case they have common denominator, so I'm going to add them together. And I'm going to multiply both sides by 15. So that's going to be 30 pi. And then I'm going to divide everything by pi. That will cross all these pi's off, leaving us with a plus 17 equals 30. Then I'm going to subtract 17 on both sides. And I get 13. So those are my two solutions. Example number 2, it says, there's a point that lies on the circle with a radius of 1. Then the exact value of k can be expressed as positive negative square root of b. Well, we know that when we're talking about a circle, the equation that we would use would be x squared plus y squared equals r squared, radius squared. Now we know what the x value is, so 0.2 squared, plus we're going to find our k value, so it's going to be k squared equals our radius, which is 1 squared. So k squared equals 1 minus 0.2 squared. I'm going to put that in my calculator, and I get that k is equal to the square root, which is positive negative, of 0.96. What they want is the b value. So the b value is the radicand, the value underneath your square root symbol. So it's going to be 0.96 to the nearest hundredth. So what we need to know for this lesson is that if we have a point xy, so if this point is a point on the terminal angle or arm, of angle theta that intersects the unit circle. So what's going to happen is when we create a point, if it goes on the actual unit circle, then we can write that cos theta is always going to be then x over 1, which is x. And our y-coordinate is sine. So that's what we've seen on the unit circle, is that the x-coordinate is cos and the y-coordinate is sine. And tan, how we find that is we always take the y-coordinate and divide it by the x-coordinate. So whatever answer you get from Sine, you're going to divide it by cos. So that's why our points on the graph, every point on our graph is going to be labeled on the unit circle as cos theta first for your x coordinate, and for your y coordinate should be sine theta. Now, we're going to look at the reciprocal trig ratios. They have their own names. So we know that the main three trig ratios are sine, cos, and tan. So we've looked at those. But then there's three other ones. They're called cosecant. So cosecant is equal to, it looks like this, cosecant. So that's the information we use. It's the same as saying the reciprocal of sine. So 1 over sine theta is the same as is what is representing the cosecant value. Then we have secant. Secant is equal to sec theta, which is 1 over cos theta. So if you guys look at the third letter in the words, that's kind of a hint of what ratio is the reciprocal. And so cotangent, same idea. The third letter gives you a hint that we're using the reciprocal of tan. So it's going to be cotangent theta is equal to 1 over tan theta. So these are the three new ratios that we're going to be using. So in example number 1, they give us coordinates. So remember, the first coordinate is our cos value and the second coordinate is our sine value. Now from this information, we know that it's actually going to occur in quadrant number 2. So we have an angle in quadrant 2. And so we know that on this, since sine is equal to 2 root 2 over 3, we know the opposite is 2 root 2. And the hypotenuse is 3. And our adjacent side to that angle is -1. Okay, so this is what I was able to label looking at those points, because remember, this is going to be our opposite side of our angle, this is our hypotenuse, and then this is our adjacent side over our hypotenuse. So we use those to label the triangle. Now they want us to draw a diagram to model the situation, which I just did. So this is the diagram for the situation, and our cast rule is there for later on. For B, they want us to determine the 6 trig ratios for that theta. So sine, we already have. Sine is always the y coordinate when we're looking at this. So it's going to be 2 root 2 over 3. Cos is equal to the x coordinate, which is -1/3. Tan is always equal to sine divided by cos. So in this case, if we take our sine value, 2 root 2 over 3, and we divide it by -1/3. So what you want to remember for this is we're always going to multiply by the reciprocal. So multiply by the reciprocal, which is -3. Those 3's will cancel, leaving us with -2 root 2. So that is our tan value. And then what we need to remember for now the other ratios, we have these new ones. This is cosecant. Then we have secant. And then we have cotangent. So remember, cosecant is just the reciprocal. So we're going to flip it. So it's going to be then 3 over 2 root 2. But we always need to make sure that we don't have radicals in our denominator. We need to rationalize. We need to multiply the top by root 2 and the bottom by root 2. So that's going to give me 3 root 2 over 2 times 2, which is 4. So that's my answer. Next one, when we flip -1 over 3, we get -3. And for cotangent, we're going to flip our tan value, so that's going to be -1 over 2 root 2. Again, we need to rationalize that by multiplying the top by root 2 and the bottom by root 2. So that gives us -√2 over 4. So those are our different answers for B. And And that is in lowest terms. We also always need to rationalize. So that's that important thing that we just did. So I'm going to outline all these answers here. So there are your 6 answers for B. So exact values, whenever they want you to use exact values, so what we need to remember and what we're using are, you can use your special triangles. So I'm just going to draw those out for you so that way you can see what I'm actually using. So remember, one of them is 45 degrees, which is pi over 4 and pi over 4. Opposite to 45 degrees should have been 1, and then square root of 2 for your hypotenuse. So this is a special triangle that you learned in 20-1. The only difference is instead of writing 45 degrees, we're writing pi over 4 because that's the radian value. And the same thing happens here. So if you have pi over 6, that's equal to 30 degrees. Opposite to 30 degrees should always be 1. Your hypotenuse should be 2, and then opposite to pi over 3, which is 60 degrees, should be square root of 3. So that's going to be helpful for us. So when we're using exact values, remember the special triangles are the 30, 60, 90 triangle or the 45, 45, 90. So whenever we see 0, pi over 6, pi over 4, pi over 3, pi over 2, those values hidden in the equation, then we know we're going to have exact answers for this. So draw a diagram to help determine the exact value of this. Okay, so we want tan of pi over 2. Pi over 2 is 90 degrees. So what I need to remember is that 90 degrees is right here. The coordinates on the unit circle for 90 degrees would be 0 and 1. This is your cos ratio, and this is your sine ratio. So for tan, remember tan is always equal to sine theta over cos theta. So if I take my sine value, which is 1, and divide it by 0, we're going to find that it's undefined. There's going to be no answer here because we can't divide by 0. Okay, so that's our first one. Our second one, a little hint is we look at this, the number, we kind of exclude that value in front of pi. So it's pi over 6, and that is your reference angle. So it's really quick to find your reference angle. And because it's 7 pi over 6, so if we had 6 pi over 6, that would be right here. So since it's 1 more than pi over 6, or 6 pi over 6, it's going to be in your third quadrant. So it's going to land right there. Okay, so our angle is here, and that one is there. So pi over 6, guys, is equal to the special triangle. We're going to look from the pi over 6 value, and we're going to do cosecant. So cosecant, guys, normally for cosecant, that's like the sine value, we would have to do sine theta is equal to opposite over hypotenuse. But what's going to happen is we're going to have to flip it. It's going to be hypotenuse over opposite side. Okay, so in our third quadrant, sine is going to be negative. So we're going to have a negative answer. And then for sine of pi over 6, we're going to look at our special triangles, and we're going to do hypotenuse, which is 2, over our opposite to pi over 6, which is 1. So I don't need to divide by 1, so that it would be my final answer. Our next one here, sine of negative 300 degrees. We know that we're going clockwise in this case, so that's going to end us in quadrant number 1. So with a remaining value of 60 degrees. So what I'm really trying to find is sine of 60 degrees. If I know what that value is, then I know what my answer is. So looking at sine of 60 degrees is the same as pi over 3. So we're going to go opposite over hypotenuse, which is equal to root 3 over 2. And then our next one is secant. Secant is the reciprocal of cos theta. Cos theta is always your adjacent over your hypotenuse. So what you're doing is you're taking the hypotenuse over the adjacent in this case. So we're going to look from 60 degrees. So that's going to be the same as saying pi over 3. So your hypotenuse value is 2. And your adjacent value to pi over 3 is going to be 1. So our answer is 2. Okay, so that's how we can use our special triangles to answer these questions. Now we're going to look at the approximate value. So you can determine approximate values using your graphing calculator. So most calculators, as long as you're in degree mode for degrees and then radian mode for radian values. So you might have to switch your formatting depending on what your calculator is asking for. So for example, you want to check to see if your calculator is giving the right answer. So you're going to go to mode. So mode will take you to either radians or degrees. In this case, we're going to be in degree mode for the first one, and just put in cos of negative 200 and check that you're getting this value here. If you are, you're good. So you can find the value of a trig ratio for cosecant or secant or cotangent by just doing the reciprocal. So there's no button that has cosecant or secant or cotangent, so you're just going to have to do 1 divided by the cos of that same answer. So that's a little hint for you. Okay, so if you put in, try 1 divided by cos 3.3 in your calculator. The mode that you're going to have to be in for this, in this case, you're going to have to be in radians because there's no degree. So it's just 3.3, which means that you are actually in radian mode. So you're going to have to switch between the modes and be careful about that. So you should have gotten here negative 1.01 if you did it properly. And there's more decimal places. I'm just rounding to the nearest hundredth. Example number 3, they want us to calculate. So in this one, we're going to have to make sure we're in radian mode. Next one, we're going to have to be in degree mode. This one, degree mode. So we want to see that little degree symbol if we're going to be in degree mode. If you don't see a symbol, that means you're in radian mode. Okay, so for the first one, for A, you're just putting, you're just making sure, one, that you're in radian mode. If you are, then you're going to go sine of, in brackets, 1.92, close your brackets, and you should get the value of 0.9396. So that's to 4 decimal places. Now, this is a positive value. This one, this value is going to be in quadrant number 1. Or sorry, quadrant number 2. So remember, pi is equal to 3.14. So this is less than 3.4, but it's more than half of 3.4. So that means it's in quadrant number 2. So also we know that sign is always positive there. So it should be a positive answer, and it is. So that's a way of checking our answer. Our next one is tan of negative 500. So we're going to make sure that we're in degree mode in this one. So change your mode to degree mode and then put in tan of negative 500. So you should get 0.8391. So this is going to be in quadrant number 3. The reason being is we're in the negative angle, so we're going negative direction. So normally that would land us in quadrant number, so that would be in quadrant number, let's see, when we're looking at it, we're going, this would be 3.14 divided by 2, so that would be 1.57, so it's less than that. So it should be in quadrant number where tan is positive. So where tan is positive, that's going to occur in quadrant number 3. So 500 degrees, oh, that's what I wanted to look at. So for that answer right there, for B, we're going in the negative direction, negative 500 degrees. So what that looks like is you'd go 1 full rotation. So that would be 500 minus 360. And then you still have 140 to go. So this would be an extra 90. And then it would land about here. So we're in quadrant number 3. And since we're in quadrant number 3, our answer is positive, as you can see. So just look at the angle and just follow along to find out where it would land. In this case, we had to be going in the clockwise direction. Here, 85.4, that's going to be in quadrant number 1. So what we're actually calculating is 1 over cos of 85.4 degrees. So that's what we're actually putting into our calculator. Now you're still going to be in degree mode. And you should be getting 12.4690. So that's going to be in quadrant number 1. And D, it's cotangent of 3. So change your mode to radian mode, first of all. Once you're in radian mode, you're going to go 1 over tan of 3 in brackets. And you should be getting negative 7.0153. Now 3 is going to be in quadrant number 2 because it's between, it's just less than, slightly less than that pi value, which is 3.14. Okay, so we know that the sign, because it's in quadrant number, for A, because it's in quadrant number 2, we know the answer is positive. And here in quadrant number 3, we know that tan is positive. In quadrant number 1, all are positive, so that makes sense. And our answer for tan is negative in quadrant number 2, which is why our answer is negative. So that's how we can justify our answer. Okay, so when we're finding the measures of angles, we're going to have to do that inverse function. So inverse of sine theta of 0.5 is equal to 30. So remember, whenever we see this symbol here, it's the inverse of sine. Do not confuse it with where you're taking the reciprocal. It does not mean that. So the reciprocal is not the same as the inverse of sine. So keep that in mind. I'm going to put a little star just to remind you of that. So sine theta, cos theta, tan theta will only give you one answer, but you're going to have to usually find out using full rotations where the answers could be. So you're going to use the domain to figure out where the possible answers are if you were to rotate around. So you have to kind of look at the terminal arm, where it lands, and how you can get there using the domain. So for example, number 4, what you want to do is you want to start by finding theta, which is cos inverse of the 0.843. So let's start with that. So cos inverse of 0.843. Now for this one, you'll want to have the answer in degree mode. So you'll want the answer to be in degree mode because they're giving you the domain in degrees. So negative 360 to 180 is the domain. So we want to do cos inverse of 0.843. Like I said, we're in degree mode. You should be getting approximately 32.5. So our angle, our reference angle is 32.5 degrees. Now we want to figure out all possible values that will do that for us. So when we're drawing this angle, using the cast rule, cos can be positive in the first quadrant and in the fourth quadrant. So in quadrant number 1, remember we can have 32.5 degrees as an answer. And then in quadrant number 4, we would go 360, subtract 32.5, that reference angle. So that's going to be 327.5. Now this one is greater than 180, so we won't include that one. That one does not make sense. So we're going to have to go in the negative direction in that. So if we were to go in the negative direction, then what we're doing is we're going this way around. So first of all, we can have a negative 32.5 degrees, right? So that's the reference angle. And then we can also have, if we were to calculate this, we would have negative 360 degrees plus 32.5. So if we take the negative 360 degrees, which is a full rotation around the circle going clockwise, and we add, meaning do the opposite sign of that reference angle, we're going to get that that's equal to negative 327.5 degrees. Okay, so these are our 3 possibilities because we needed to go from negative 360 all the way to positive 180. So these are all between those answers that will give us the same 0.843 answer. So they wanted our answer to the nearest tenth, which we've done. So that is A. B, for B, we're going to start by, in this case, whenever it's 0 or 1 or negative 1, I'm going to use the quadrantal angles, the unit circle, and label it. So this will be 1, 0, this will be 0, 1, this will be negative 1 and 0, and this will be 0 and negative 1. So they're saying, when is sine going to be 0? Well, sine is always the y coordinate. So I'm going to circle where that happens. So sine is 0 here, and sine is 0 here. So we need to write down every time that happens. So if we're going around the circle, they want us to go from 0 to 180 degrees. So those are our 2 possibilities. 0 degrees and 180 are our only answers. So 0 degrees is one answer and 180 degrees is the other answer. C, what we're trying to find is the inverse of that. So we're trying to find out what the inverse of, if I have cotangent of negative 2.777. So what I want to do is I want to find tan theta instead, but I need to flip the answer. So it's going to be negative 1 over 2.777. So whenever you have the reciprocal relationships, you need to do the inverse of the answer. So that means I'm taking tan theta, or tan inverse of positive 1.2777. We always put the positive value of it to get our reference angle. So tan theta, 1 divided by 2.777 in our brackets gives us 19.8. But we do have to be in this one, because it's 2.77, we should actually be in radian mode. So switch your mode or you will get the wrong answer. So now try again, 1 divided by 2.777. You should be getting the answer of 0.3, I would say 5. Okay, so that is our answer over there. Now for this one, we are in radian mode. Okay, so the answer has to go from negative pi to positive pi. So between negative 3.14 and positive 3.14. Okay, so in this case, we also want to look at where the answer can occur. So tan is negative in your second quadrant and your fourth quadrant. So we need to use those. And so when we're going in our positive direction, we're going to stop at pi. So we need to find out what this answer is right there. So that would be like saying pi subtract 0.35. So pi subtract 0.35, because pi is equal to 180, you'll get 2.79. And they do want the answers to the nearest 10, so we're going to round it to 2.8. So that's one possibility. Our other answer is we're going to have to go in the opposite direction because it says we have to go into the negative pi region. So our answer would be this right here. So that would be like saying negative 3. It would be negative 0.3. So if I'm going this direction, this angle right here, guys, is negative 0.3. So that's another answer. And then we can still keep going, but if we were to go on, it would go past pi. So those are our only two answers. One going into the counterclock direction and one going into the clockwise direction, counterclockwise and clockwise. So those are our two solutions right there. And lastly, D here. We have to flip it first. So that means that sine theta is equal to negative root 2 over 2. So we flipped it first. Our next step is to go theta is equal to sine inverse of root 2 over 2 to get the reference angle. So in this case, we have to be in radian mode as well. So make sure that you're in radian mode. And then we're going sine inverse of root 2 divided by 2. And you should get the value of, now in this case, so here we're getting the value of 0.785, but they want exact answers. So whenever it's exact answers, a little hint is it's going to be those special triangle numbers. Okay, so what I'm going to do is go back to the special triangle kind of picture just to show you what that would look like. So remember in our previous lesson, you should have seen our special angles. So our angles were this. So they're saying when is sine going to be equal to negative root 2 over 2? So you want to look at any time around the circle that it's equal to negative root 2 over 2. So that's the y coordinate. So I can see that that occurs here where it's 7 pi over 4. But that's going to be greater than pi, so we can't include that one. So remember, we have to go into the direction of positive pi and then negative 2 pi. So for positive pi, pi, we're going to look for where you have negative root 2 over 2, and that's going to occur, that's not going to occur at all. So if you look in, if you look from 0 to 180, guys, the y coordinate, there's never a point that is negative root 2 over 2. So that means I'm not going to look at that direction. I'm going to look at negative pi direction. So I'm going to go in the opposite way and look for where that could occur. Okay, so negative root 2 over 2 occurs at 7 pi over 4. So I'm going to write those numbers down. And at 5 pi over 4. Okay, so I'm just looking at the angles where that happens. Okay, so those are the only two. If you look at 5 pi over 4 and if you look at 7 pi over 4, that's when you can see that happening. Now the trick to this is if you want to find out what the actual, what the values are, so we have to go in the negative direction. So we need to figure out what those are if we were to kind of flip this around. Okay, so what I would do is I would go 2 pi subtract 7 pi over 4. So that would be the same as saying 8 pi over 4 minus 7 pi over 4. So that's equal to pi over 4. And remember, we're in the negative direction, so we have to write minus pi over 4. Okay, so that's one possibility. Our other answer, so we're going to take the 5 pi over 4, and we're going to also subtract it from 2 pi. So that would be like saying 8 pi over 4 minus 5 pi over 4, which is equal to, again, negative 3 pi over 4, because we're moving in the opposite direction. We're going into the clockwise direction, so they do have to be negative angles. So that's how I get that answer. That's kind of like a trick using the special triangles. Okay, so I'm just using the numbers and subtracting it from 2 pi, and it's giving me a negative answer. Okay, so that's how I got those two. Example number 5, they're giving us a point on the terminal arm. They're saying, what are the exact values of each trig ratio? So first of all, we're going to plot that point. -5 and -12 takes us into the third quadrant. Now we draw that triangle using that reference angle. -5 is your x value, -12 is your y value. Now I need the radius, so I'm going to do Pythagorean theorem. So that's going to be 5 squared plus 12 squared equals r squared. So if I add those two numbers together, 25 plus 144, I get 169, which means if I square root it, I get 13 for r. Now that I have the r value of 13, now I can go and write out the ratios. So I have sine theta, cos theta, and tan theta. But our new ones that we need to include this year are, we have cosecant theta, we have secant theta, and we have cotangent theta. It's always that third letter that tells you, or in this case, the second letter here, that tells you that which ratio you're actually using or comparing it to. So cosecant is just the sine, the reciprocal of it. So sine, we're going to look at the opposite side divided by your hypotenuse, so that'll be -12 over 13. Always simplify your answers as well, because they do want exact answers. Cos is equal to your adjacent side, which is -5 over your hypotenuse, 13. And your tan is equal to your opposite over your adjacent. So -12 over -5 is 12 over 5. Okay, so those are exact answers. Now for the next one, we just have to flip the answers. So for cosecant, we just have to flip it. So instead of -12 over 13, it'll be -13 over 12. And then for cos, we're just flipping that to give us -13 over 5 for secant. And for cotangent, it'll just be 5 over 12. Okay, so those are our exact values for our trig ratios. Okay, so that